I got a call from a Danish regatta association. They wanted to use my StopWatch application to time the beach sprint regatta. That is possible with 6 easy steps. Acquire a link to the application from me, download and install, create a regatta, create a race, start the race, and mark the finish times. But this speed sprint regatta wants to time the race finish automatically, and that required some extra hardware to read the button or buzzer the team presses on the finish line. My idea was using a general purpose input-output module, for short a GPIO module. I had a contact of mine design and fabricate the GPIO module for my box loader project. The firmware in the GPIO module is a piece of software I have written myself, so I could claim I have control of the whole chain, except Windows, a USB standard, etc. etc. And a relay to separate the button from the GPIO module. To separate the circuits and make the construction more noise resistant when using long wires going to the buttons. And if more voltage is needed because of the cable length, an external power supply can be added. A button to pull the relay. The relay puts 5 volt to the input pin in the unpowered state. The relay puts 0 volts to the input in a powered state. The GPIO module is configured to use edge detection when the power goes low. On the PC, make a dedicated program to set up and read the GPIO module packages. When a GPIO package is received, the program sends a package to StopWatch. Configure StopWatch to mark a finish time when the appropriate package is received. Finding the needed hardware in my drawers and boxes. GPIO module, relay, a box, and plugs. I could have 3D printed a mounting plate to hold everything together that fitted the side slots of the box. But making 4 small brackets to hold the plexiglass plate in place with a few screws and nuts is faster on print time and assembly, when it's only one piece to assemble. If I had to make multiple boxes, my design process would take longer and concentrate on using far bigger and standardized parts. Drilling holes for the plugs could be done with a CNC machine, but again, I don't have a CNC machine and it's only one box. The end result for the first steps. And next step is the holes for the plugs. Connecting the wires. Connecting the relay contacts, normally open to 0 volt, normally closed to 5 volt, and the common to the GPIO input pin. One of the coil wires to the 5 volts power supply, and the other coil wire to the 0 volt supply through the plug for the button. Test time. And what I thought should be a final test before mounting the wires and closing the lid, revealed that one of the relays was defective. Mounting plates out of the box. Loosen the relay board. Testing new relay board to eliminate wire failure. Replacing the relay board. And just for good measure, test the relay board when it's remounted. Remount the electronics in the box and test the whole thing again, just in case something has loosened. Good test, all works. When I build a device like this button interface for the StopWatch application, the process of going from idea through design to a finished product that works is really what drives me. Finding the best suited parts for the right price and making them fit in one piece of hardware. It is a rewarding experience when the assembly is finished and the product lies in front of me and I can reach out and touch the result. But what really makes my day is being able to make a program that uses this new piece of hardware. to see the whole thing come together to a solution that the customer can use, and that the product makes their daily life easier, even though it's only for one regatta a year. What you see here is the main program, all the integrations for telnet connections to the StopWatch application, and the USB communications for the GPIO module are reused from previous projects. 107 lines of code to read a USB device and send data to the StopWatch application is kind of a long program, but most of the lines are for error handling and keeping the user informed in daily usage and error scenarios. Activating each relay in turn. The program acknowledged the input on the screen. The StopWatch application is not running, hence the error message. One issue with using relays is their power consumption. The more relays there are, the more drain on the power supply. A normal USB-A is specified to supply 500 mA. In this case, more than enough even when both relays are activated at the same time. The GPIO module I use has 8 inputs and 8 outputs. I have an extended version of the module that has 16 inputs and 16 outputs, but having 16 relays drawing power at the same time will most likely cause a USB power shortage. On top of that, the cable length needed to reach 12 rowing lanes might require wires up to several hundred meters, and a 5-volt signal might have trouble traveling that distance or pick up noise on the way. If the distance becomes an issue, a 9-volt or 12-volt power supply can be implemented, as the relays are easily decoupled from the GPIO module's power supply. Another possibility is to use some serial communication when or if the distance issues arises. But that requires another design, and that might go in the direction of RS485 communication, using the Modbus standard. Thank you for watching, and see you next time.